Hello folks, working with a new board here, so I'm trying to adjust to the height of this. I hope you will forgive me for the silliness of hovering here. Anyhow, I'm going to get into the first chapter that we have, which is chapter 4, the systems of numeration, right, which is a fancier way basically of saying number systems. Before I do that, let me just go over a couple of things about the syllabus. By now you probably have you've read the announcement, so I'm not going to go into it too in-depthly, but I just want to point out two things. Here's the syllabus as it would be printed. The way that I wrote it is so that the two most important pages are the front and the back. Right? It's not that the things in between are not really important. They are, but they're more formality. This is where the practical information is, right? Basically, I made a little square here so that you could sort of write whatever your identification is for creating your MyLab account, right? A person had asked me a good question. They said, do we need the textbook? Well, this is the physical copy of the textbook. You don't really need it. Your assignments are in my math lab. All right? They come from this. The material comes from this, and if you buy the software license, it will naturally have an ebook. I'm a little old-fashioned, I suppose, so I like a hardcover. But you don't have to actually have that, right? I'm not going to be assigning things from the textbook specifically. What I would advise you to get is a scientific calculator. This is the type that the math department recommends. It's a Texas Instrument. It's more or less the $10 to $20 variety of a calculator. You don't need a graphing calculator. Right. Perhaps if we get into statistics, it would be useful, but you're not obligated to do that. As for how the semester will be graded, the majority, as you can see from this pie chart, right, the majority of your grade comes from the homework assignments that you do in my lab. So put all your effort into that. Right? There is going to be some tests and a final exam, but you could see that they're 25% each compared to 50%. So you really are here for the sake of preparing for your praxis examination. And how would you do that? The experience of doing your MyLab assignments. Okay. If during the course of the semester you're sketchy about where we are, look at the calendar. I have this posted in Canvas as well. These numbers that you see here, 4-1, 4-3, 4-4, and so forth, all right, are the days and the section numbers as they would be outlined in the textbook. All right, so like today we're going to do section 4-1. If again you need to know where we ought to be, right, ideally this is where we should be. I'm going to try to make this a regular Monday, Wednesday class. Okay, forgive me if it takes a little while to upload the video. It depends on how long it is, and sometimes there are technical reasons that I can't get it uploaded fast enough. Anyhow, enough of that. Right? Make sure that you have that. The other thing that I'm going to have available to you in Canvas through announcements is this packet that I've made for today. Right? This especially. I basically swiped these diagrams from the textbook. These are useful for translating between different systems. Right? That especially. This is a diagram that I use a lot myself. I made this. If you had me for the last semester, section 113, right, I've given you this table a lot. It's basically for terminology. We'll use that periodically. And then there are some example problems, which again I swiped from the textbook. I'm going to walk you through these basically over the course of the video here. All right. So let's get into that. Put this away. I have to crouch a lot, I'm sorry, but it's good posture. I'm thinking, not to belabor the point here, I may end up having to move this because it's such a monstrosity and I have a very confined work area. This is actually the staircase where I live. All right. Okay. Now we are basically going to do section 4.1 today and 4.1 only. It's quite involved. It's a fascinating subject. It has to do with ancient history, really. But it's kind of a novelty. It's not the sort of thing that you would deal with ordinarily in real life. Take for granted the system of numbers that we use already without having to explore older ones. But for the sake of comparison, right, that's what we're going to do. We're going to look at older number systems. All right. Let me have you take out that sheet, as I mentioned, from the packet that looks like this. This is just to get the terminology out of the way. Okay. And I've made a larger version of this. And we'll go through this. All right. This may sound silly, but let's give a definition to the word number to start with. Again, we are in section 4.1, so if you want to label it as such, that's fine. All right, a number is a concept, and just for the sake of clarity, let's just say it's a quantity, right? That answers the question, how many? Signifies that. Let me just push my little thing back here. Good. All right. We in vernacular English will probably use the word number and the word numeral interchangeably, but let's make some distinction here. This is fading out on me already. All right. The by marker. All right. Another one here. Numeral. Numeral. No. All right. For the sake of distinction, a numeral, even though we will use these two words interchangeably, a numeral is the actual drawing, right? It's the symbol, right, that represents the quantity. As for this last concept, this phrase, system of numeration, that is a fancy way of saying number system. Numeration. It basically consists of a set of numerals and a scheme. All right, or a rule, you might say, for combining. This is again for the purpose of to represent numbers. Sorry for the sloppiness or the squeaking. All right. Anyhow, so just know this terminology. It's pretty straightforward, right? Number is a quantity. It's the concept. It's the abstract idea of how many. A numeral is the actual picture. And a system of numeration is the set of the pictures, the set of the numerals, and the scheme, the plan, the rule, the strategy, if you want to say it, for combining. Okay. All right. Put this out of the way here. Pull down the stairs now. Let me give you a little timeline. This is imperfect, admittedly, but I'm not teaching history, so I will not be held accountable. give you an idea. Slipping the line. It helps to sort of place your systems in a timeline of history here. So let's do that. If you can imagine, maybe I'll draw a nice line here with my extra long sheetrock folder here. This is my closet. I'm just absolutely terrible at drawing straight lines freehand, I've noticed, so it kind of helps. If we were going to place our number systems in the timeline of history, this is getting flat, let's see. Let's think about it this way. Prehistory would arguably be 4000 BCE, something like that. Maybe 5000, it depends on who you talk to or what textbook you read, I've noticed. But in prehistory, the system for numbering existed, but it was nothing more than, say, scratches in a piece of bone, all right, or on a stone, all right, or notches in a piece of wood. Or knots in a rope. To keep records of some sort, all right? It's not a written numeral or number, right? But it keeps track of numbers, the quantities, all right? A little bit further down the pike, we have Mesopotamia, which is modern-day Iraq, and that's where historians seem to indicate where history begins, recorded history, right? That is a written history with actual symbols of some sort. That's something like 3600 BCE. You don't have to know these dates, and they're sort of questionable anyway, but to give you a vague idea. The sort of technology that we had, humans, right, for keeping records of quantities of, I don't know, grain, cattle, what have you, all right, was a little bit more sophisticated. We were using clay tablets, right, and a stylus of some sort. All right. And think about that. The technology, although it's fine, you know, it worked, is not that sophisticated, so there are some constraints naturally. If you're writing in clay, all right, without having some trouble, you might at best just sort of leave impressions in the clay. So the style of writing is referred to as wedge-shaped. And you'll see probably in section 4.2, where we get into Babylonian arithmetic, you'll see some diagrams pertaining to that. All right, if you've taken a history class, very likely you've seen some examples from some, at least photographs of a stone or clay tablet with sort of boomerang sort of impressions, something that looks like this. Pressed into clay, right, to represent a quantity. I'm sorry, I'm being hailed by somebody. What do you want? You want my blood, apparently. Okay. There's a blood drive. Okay. Alright, sorry. Pardon me one moment. A little bit further, let's let's just say something like 3200 BC. You have Egyptian civilization. And the technology moved forward a little bit. Right? Not necessarily at this exact date, but the Egyptians, which became sort of the locus of Western civilization at least, employed scrolls. Perhaps a reed or something to use as a stylus. The only reason I'm mentioning is that the technology has some bearing on the aesthetic, basically, of the symbols. You'll see if you examine this chart, right, just how sophisticated they were. All right, here's our standard numbers that we have, right? All right, and these are Egyptian symbols, at least. Right, there's a little picture of a person, which I find funny because it's referred to as astonished person. It's like. I guess that's what you had to do back then. The Chinese characters you notice here are very pretty. They look as though probably this was done with a brush. I don't know at what point brushes were invented, but a brush and an ink makes a fine sort of artistic sort of character. All right. Eventually what we're going to get into today is traditional Chinese, believe it or not, which would probably be a little bit after this. Ancient Greek, and then Roman. So you figure Roman being something like 500, this is maybe something like 800. China is something like 1200. And then there's the actual system that we have, which is falling off my scale here. Right? What is referred to as the Hindu-Arabic system of numeration. Basically, these characters, as we take them for granted, right, are somewhat of a misnomer referred to as Arabic numerals because there is evidence that it actually comes from India. But Europeans, which have had such a bearing on American history directly, took these styles of writing numbers probably from North Africa and the Middle East, right? And they themselves, the people living there, took them probably from India, right? So we refer to our system of numeration, numbers like this, if you will, all right, as being the Hindu-Arabic system. And it's really the best system out of all of the systems through history, if for no other reason that it includes the numeral 0. Right? In order to do more sophisticated math, we need 0. Romans, for example, did not have 0. They had no picture for it. Right? To them, it would be silly to have a picture of something that represents nothing. But indeed, to do something more abstract, like algebra, you would need to have that symbol. All right. Now, let me give you another diagram here, and then we'll get into some examples. To summarize this class worth of material and the forthcoming class, let me draw you a diagram like this. All right, we're going to be discussing basically 4 types of numeration systems. Systems of numeration, however you want to say it. Number systems. In comparison to what we're using. Right, so I'll just put this sort of thought cloud up here. These 4 things in contrast and comparison to our beloved, rightfully, Hindu Arabic system, which again is what we use today, right? The superior system for numbers. Let's see. The first type we're going to talk about is referred to as the additive system. Or this is an example of this type. Additive systems. And then also multiplicative. And Siphon. That's primarily today. I'll get out of the way in a second, I promise. Right. And then the forthcoming would be place value. Essentially, additive systems are section 4.1, multiplicative systems are section 4.1, Siphon systems, at least the type that we're going to start with, is section 4.1, and the one that we're not going to cover today, but we will in the future, place value systems, would be starting in section 4.2. Let's see. The examples of additive system we're going to see are these. Ancient Egyptian, and Roman. Multiplicative systems, we're going to explore traditional Chinese. Fading out a little bit. That's legible. There's a little dud in it works here. And for a Siphon system example, we're going to look at ancient Greek. What they call Ionic Greek. Sounds like chemistry. I think it's Ionia is what it's referring to. Let me see, is that in frame? Okay. Alright. And again, keeping with an overview here. I hope these don't die on me. I need them to work right now. Let's see. An additive system, another word to describe it might be iterated or repetitive. It's basically establishing a character to represent a number, right, and drawing it multiple times. And in the case of the ancient Egyptian hieroglyph, that could be done indefinitely, right? The Romans were a little bit more strict, right? There was like no more than 3 of the same type of character in a row, you'll see. Basically, a number represented is the sum of the values of the numerals. Okay. Ancient Egyptian is really, if you had to just sort of compare it or refer to, I'm trying to think of the word here, in terms of math, right? The sophistication of the level of mathematics in ancient Egyptian is really addition, right? Subtraction is a little bit more sketchy, right? It's just simply not drawing something. the Roman numeral system really is adding and subtracting. It's a little bit more complicated because in the case of the Romans, order of the numerals matters. Fade now too. Okay. It's a little bit better. I have to buy markers later. This is a little bit more strict. Traditional Chinese basically involves multiplication. That the example, at least, that we'll see. In ancient Greek, is more or less adding again. We'll see in terms of the type of operation involved. All right. So let me give you some examples of these, and I'll sort of walk you through them. Let me erase this because I need a space. It gets a little dark. I'll turn the light on. I don't really like it though. Alright, what I would have you do is now, if you have this printed, let's go through these 10 examples as part of the packet. Alright, and especially refer to these tables here for translation, if you will. First thing we'll do is example 1. All right, we're going to translate ancient Egyptian to the Hindu-Arabic system. Of numeration. Okay. Now what you'll see is an example, and I have to unfortunately draw this. I never thought I'd be drawing hieroglyphs, but I must. If you are given these hieroglyphic symbols in sequence, we'll translate this into more or less a regular number. If you look at this diagram that is on our sheet here, all right, refer to the symbol drawn in the example, all right, and then write it underneath it. So what you'll see is that if you have what are described as 3 pointing fingers, all right, one pointing finger apparently was used to represent the amount of 10,000. So if you have 3 of them, you would write 10,000 3 times. Yes, of course, because we're aware of a more sophisticated form of math, yes, you could write that as 3 times 10,000, but humor me, all right? 3 pointing fingers, all right? Our ancestors came up with this, right? It's funny, all right? 10,000, 10,000, and 10,000, which are just simply going to be added. Again, it's repetitive, or you might say iterated. You're literally drawing the same character 3 times, or many times. Then you have these symbols, all right, which to me are sort of, they look like, the way I've drawn them, they look something like 9s, but I have not drawn them well, all right? These are sort of cinnamon roll shaped things. These are scrolls, all right? If these are pointing fingers, these are scrolls. The pictogram for a scroll as it would be from the side, right? right? That, again, if you refer to the table, you see here a skull represents the quantity of 100. So this is 100 plus 100 plus 100, right? Then there's this character, which to me looks like a horseshoe, but it's referred to as heel. I don't know if that's literally like the back of your heel or the impression your heel would leave in the ground. That's actually 10. And then we get into something slightly more intuitive, right? If you think about it, actually, especially as you compare one system to another, the basic quantity of 1, which is what each of these would be, and these are called staff, right, in this case. There's no imagination there, all right? Virtually every civilization seems to have gone, it's that symbol, all right? Probably because it was derived from our hands anyway, right? That's 1. Even if you look at the prettier sort of brush strokes in traditional Chinese, it's just sideways, right? Arguably, right? It's a horizontal version of this symbol. All right, and here's the Roman numeral I, or tally marks, right? Okay. Anyhow, that just represents the quantity of 1. So this is 1 plus 1 plus 1 plus 1, right? And then it's just a matter of adding all this stuff together. So if you have 10,000, 10,000, 10,000, you have naturally 30,000. If you have 100, 100, 100, that's 300. Plus 10, plus 4. Right? If we were to sort of write it the way that we were taught in grammar school, all of these would be lined up according to place value. And then you would have 30,314. This is the Hindu Arabic, the standard way of writing the quantity, 30,314, and this is as it would be in apparently ancient hieroglyphics. Pointing finger, scroll, 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 horseshoe, and 4 stabs. I think that's charming. To think our ancestors went through this, right? You can see why it's beneficial for us already, all right? This, although it works to keep account of an amount of something, it's kind of cumbersome, right? And all it is just adding, right? If you were going to do subtraction, you simply would neglect to write one of these symbols, and it would be one number lower, all right? So 313 instead of 314. Number 2, all right, if you were going the other way, if you were going to translate from Hindu Arabic to ancient Egyptian, and you started with this number, given 1 million, pardon me, I'm waiting for a very important phone call. Hello? What is this in regard to? Oh, okay. I'm he. Yes. sorry. I didn't want to cut off the video. The phone call that I had was from social services. I've been waiting a long time to talk to them, so I didn't want to not speak to them. Anyhow, let me get back to this. If we are given this number, right, 1,203,000, this is a little bit faint, 462, and we're going to translate it back into ancient hieroglyphs. That's very faint. Let me see if I can get to this. That's a bit better. Let's see what we can do. Okay. All right, again, refer to the table that I have for you. Okay. Look at the place values, basically. We have a number that stretches as far as the millionths place, right? And we have, apparently, from our table here, the quantity of 1 million unto itself, with a funny character, the astonished person. So, this by itself would be this person looking like so. Then we have this quantity, all right, sitting in the place value of the hundreds place, and we have therefore 100,000, and then a second 100,000 to account for 200,000. This again is 1 million. This place. Okay. Look at the place values. Let's see. All right. According to the diagram again, the power of 10, that would be 100,000, would be 10 to the 5th, right? Is a tadpole, or some people say it's a whale. So since we have the quantity of 200,000, we would have one tadpole and then a second tadpole to account for this 100,000 and then the second 100,000 to make 200,000. There's nothing in the 10,000s place to account for. We have 0 here. So we'll skip that and we'll go over to the next one, which is sitting in the thousands place. What is sitting in the thousands place is 3. So we have therefore 1,000 plus 1,000 plus 1,000. And look at the power of 10. Again, that pertains to 1,000. According to our hieroglyphs here, we have a lotus flower, which is a bit tricky to draw, but it would be something like this. I want to say it's a crescent, and sort of a downward pointing arrow, and then a sort of oval shape. I don't know why, it sort of reminds me of Mario Brothers. But it's a basic shape like that. Okay. And then you have, let's see, something sitting in the hundreds place. So it's 4, so therefore there's 4 hundreds. 100 plus 100 plus 100 plus 100. And the symbol that we have for that is scrolls. Cinnamon swirl here, hieroglyph is 100. So since there are 4 of them, you would attempt to draw, that's not right, something that kind of looks like a 9. It's a scroll in profile. And then for the 6, this is the tens place, so that's the heel symbol. 10 plus 10 plus 10 plus 10 plus 10 plus 10. 1, 2, 3, 4, 5, 6. So you would have sort of a horseshoe, a horseshoe, a horseshoe, a horseshoe, a horseshoe, a horseshoe. I imagine that if one of our ancestors could hear me referring to it as a horseshoe, they might be annoyed. That's not a horseshoe, it's a heel. Alright? So sue me. Okay. And then lastly, we have the 2 sitting in the 1's place here. So that's sitting in 1's place, so it's 1 plus 1. All right, and the symbol that we have for that is intuitively the staff symbol, so it's like that. If you were going to write it nicely, which I'll do here to summarize, the quantity of 1,203,462 in ancient Egyptian hieroglyphics would be the astonished person, followed by the tadpole, and then a second tadpole. And then the lotus flowers, scrolls, and then heels, and then staves. This quantity is this quantity. And again, you could already see how the Hindu-Arabic system is much more practical, all right? If for no other reason than that this is longer than this. Okay. Astonished person, I'm gonna use that a lot. It makes me happy. Let's see, how are we on time? Okay. Quick side note. The Egyptians did not have the symbol for 0. I would have to guess probably for the same reason that the Romans didn't. Because 0 in their thinking is, well, if it represents nothing, why would I have a picture to represent nothing? They didn't have that symbol, so they would simply not draw something if something didn't exist. But they did understand fractions. And they had what we might call, I don't want to corrupt your opinion, but another odd symbol to represent a fraction. So if you saw something like this, sort of an oval shape, right? This implies a reciprocal. I.e. essentially a fraction. So if you had something like this, that oval shape and then 3 staves, right? The quantity on the bottom is 3, and the quantity on top would be, the reciprocal of 3 is 1/3 as we think of it in Arabic system, Hindu-Arabic system. If you had something like this, heel and a staff, the quantity down here is 11, so since this is implying a reciprocal, it would be 1/11. Let's get into Roman numerals. This is still additive systems. Let's see. If you're going to read Roman numerals, I went to Catholic school myself, so this is kind of one of the things that they used to teach us. Some points to keep in mind. I'm going to neglect to use numbers of some sort and just simply use bullet points here. All right. They use letters to represent numbers, numerals. You read left to right. So in this fashion, there are no more than 3 iterations same symbol in a row. And then there's adding and subtracting. Right? Again, this is slightly more sophisticated than the Egyptian hieroglyphs in that they really had a fuzzier form of subtraction in that they would just simply not write something. Right? They would just simply add, right? At least insofar as the information given to us by our textbook. To add in Roman numerals, all right, you would follow this rule. Right. If the symbol on the left is greater than the symbol on the right, then you would add. Here's an example of that. If you had Roman numeral V and then Roman numeral I following it. All right. Again, for reference, if you're not familiar, here's a translation from Roman numerals to the Hindu Arabic system. They go up from 1 to 1,000. V is a 5. So the number on the left is greater than the number on the right. An I is intuitively a 1. You're going to add these, which means that this is really 6. Right? If, on the other hand, you had to subtract, right, it would be that situation more or less reversed. The number on the left would be less than the number on the right as it's written. So if you had the same exact symbols, but the arrangement was different, the numeral 1 in front and the numeral V after it, the number on the left, numeral I should say, is therefore less than the number of the numeral on the right, 5, so you subtract. Now here's the thing, don't, even if you want to, right, don't do this, all right? Even though intuitively that's really how you would do it, right? Because in theory, this would give you a negative number if you wrote something this way. In the level of math that we're familiar with nowadays, right? We have the concept of integers, right? The Romans did not have the concept of integers, all right? Anyhow, what you really need to do is just simply do that, right? The 5 in theory would be in front if you're translating it into what we do now, right? Just to circumvent an issue with a negative. There's no negative quantities. This is just saying, subtract these two things, you get 4. If you've ever seen Rocky movies, all right, they use Roman numerals a lot, right? If you've ever seen the movie Jaws 1, 2, 3, I think they would use Roman numerals a lot. Okay. Anyhow, this is greater, this is less, because of the orientation of the inequality symbol, like so. Point here, point here. Okay. There's one other thing, they had a form of multiplication as well. Let me slip that up here. Bar notation signifies multiplying by 1,000. Right. For basically quantities, above 1,000, this is a bit faint. Let me see if you can see that in the view of the camera here. That's kind of alright. Greens are always trouble. Let me point at this again. Notice that what the Romans had established were numerals for these specific numbers. There's a finite amount of them, which makes it an easier system compared to, say, something like Ionic Greek we'll get into. But, all right, it's, you know, you'd have to do subtraction in order to get the quantities in between these. So you have a number, a symbol for 1, for 5, for 10, for 50, for 100, for 500, and for 1,000. All right. if you needed to do something above 1,000, right, you could in theory put like two M's, right, M and then like 2,000. If you've ever seen at the end of the credits of a movie, a lot of times, just for traditional reasons, they put, you know, the date in Roman numerals. So you might see MM and then XX for 2020. All right. If you wanted to multiply instead of add, you would incorporate this. Bar notation, if you will. If there's a bar over a symbol, that signifies multiplying by 1,000. Okay. Let's do a couple of examples and we'll do something that explains that a bit better in a moment. Are we on time? Okay. All right. Let me erase this. Okay. All right. Again, referring to the packet questions, this will be example 3 from this slew of problems here. Example 3. If we were going to translate Roman numerals to Hindu Arabic, right, and you were given something like this. MD CC LXX. This looks like the Super Bowl now, right? VI. Okay. We have established quantities by letter here. So M is 1,000, D is 500, and there are two C's, so that's 200. This is 100 and 100. L is 50, and then there's two X's, so that's 10, so that's 20. And then you have the situation down here. You always compare things in sets of 2. Right? Compare 2 symbols at a time. The number on the left is larger than the number on the right, so you're going to add these. So if it's 5 is greater than 1, add 5 plus 1, and you would have 6. Right? Now if you added all of these together, at least historically we would stack them. I'm not going to drive you nuts, but let's see. You would have it arranged like this. And all the place values would line up like so. And I gotta get another red. And you'd have 6, 7, 7. Familiar date for us Americans, right? 1776. Is MDCCLXXVI. Okay. If we were going to go the other way, no, same thing. Okay. Something slightly more complicated. This is still Roman to Hindu Arabic. CM L X I V. I'm setting a bad example. Kind of the last problem I had done. I sort of did it hurriedly, hastily. It was correct, right? But when you're doing this, you really, especially because I'm familiar with it, is the real reason. But if you've never seen Roman numerals, again, the precautious strategy would be compare two symbols at a time. So, and then follow your rule for adding or for subtracting. Let's take these two. Let's compare these two. This is 100, and this is 1,000. The relationship between them is that the number on the left is less than the number on the right, so therefore you subtract them, right? 1,000 minus 100 is really 900. Right. Then you do the next set. This is a 50, and this is a 10, and this is the relationship, right? 50 is greater than 10, so therefore the number on the left is greater than the number on the right. You're going to add these. 50 plus 10 is 60. And then you have this situation. This is 1, which is less than 5. The number on the left is less than the number on the right, therefore you actually subtract and you get a 4. Right? And if you combine these, 9, 64 is your outcome here. Right. Let's go the other way. If you're going from Hindu Arabic to Roman numerals, and you have this quantity. $439. Let's see if that's visible. It's faint. I got a better green here. That's okay. All right. Again, let's refer to our choices here. All right. We have symbols established in Roman numerals for 1, 5, 10, 50, 100, and 500, and also 1,000. Is the number 400 available? It isn't. So in order to establish that, we would have to either add or we would have to subtract. Basically, what you will ask yourself as you're reading from left to right in Hindu Arabic numerals, all right, is the quantity available? All right. If it isn't, then you're either going to add or you're going to subtract. In this case, we have a symbol for 100 and we have a symbol for 500. Namely, we have a C and we have a D. So how would you get to 400? It's not available. It basically would come from, well, there's two ways of thinking about it, and one of them you're going to rule out. If you were going to acquire this quantity via adding, you would use C's, all right? So you would have 100, 100, 100, and 100, which would be a C, a C, a C, and a C. There's a problem with that, though, all right? The rule that has been established by the Romans, apparently, is that you can't have more than 3 in a row of the same type, all right? That would be like that's what would be like ancient hieroglyphs. They didn't care how many times they wrote the heel symbol. They could do it 6 times, 7 times, 8 times, whatever they wanted. But the Romans decided, no, no more than 4, no more than 3. So we can't add in a scenario like this. We're going to have to subtract. How would we accomplish acquiring 400 in that case? Well, we would have to take 500 minus 100, in which case we would have a D to represent 500, and we would have a C to represent 100. Just realize that what causes subtraction is this situation, where the number on the left is less than the number on the right. This causes or counts for subtraction. So the appropriate way to write this is not DC, that would be adding, and you get 600 in that case. It would be this. 100 is less than 500, so this would be CD. From here on out, afterward, it's okay. It's pretty easy. All right. When we get to this place, 30, right? 3 sitting in the tens place is 30. Again, look at the diagram we have for reference. Do we have something that equals 30? No, but we have a symbol for 10, right? And in this case, we're either going to add or we're going to subtract to get to 30, right? Can you add? Always try, right? Yeah, 10 plus 10 plus 10 is really x plus x plus x. All right, we've hit the maximum, but we haven't exceeded it, so we can just go with that. All right, so you would have x, x, x here. And then there's the last thing, which is 9. Again, 9 is not established in our table, right? We don't have a symbol for 9 specifically, so it's either going to be acquired by adding or by subtracting. If you were going to add, right, and you'll see why that's not going to work. You might use a bunch of 1s. Well, we'll go with the slightly larger quantity of V or 5. Adding 2 5s would overshoot it, right? So a V and a V would be 10, right? And in which case you might as well just go with an X in that case. What would accomplish something like a 9? Not adding in this case, we're going to go with subtracting, right? So if we have, again, 9, how do you get 9? It's really 10 minus 1, right? Which intuitively would be x minus I. All right, Roman numeral x minus Roman numeral I. But the arrangement has to be like this. The I in front and the x after it, unfortunately, because they are not aware of negatives, right, the Romans. So you would have this. These two in tandem are a subtraction, because it's 100 minus 500, so that's 4. These are adding, just 3 x's, and these two in tandem are subtraction. Right? It's 1 minus 10, which is really supposed to be 10 minus 1, and you get 9 in that case. All right, let's see. All right, let's get into an example of bar notation. This would be example 6, technically. If you're going to write a large quantity, that is something bigger than 1,000, way bigger. Something greater than 1,000. In terms of powers of like magnitudes of 10, really. If you had something like this, 12,345, all right? Again, if we were going to stick with adding, you're never going to get to 12,000, right? Because you would hit the obstacle of, I'm not allowed to have more than 3 of the same character, so no more than 3 M's for 1,000 in a row, which is just 3,000, and that's very far short of 12. So, what can you do? All right. Well, let's think about it this way. This is really 12 times 1,000. And we have a letter for that, M. That's a bit faint. do have a letter established for 1,000, so it would be 12 times that. How would you establish the number 12 by itself? It would come from adding, because it's a number that's bigger than 10. Right? So it would be 10 plus 2, which means that would be x and then 2 i's. Okay. Now here's where bar notation comes in handy. All right. What you will see is that rather than just have x and then 2 i's, because that's just the number 12 by itself, is that they will try to signify that we're multiplying by 1,000. This is dying too. I just bought these. So what you will see to signify this of multiplying by 1,000 is that they will take those symbols, x and then 2 i's, and then put bar notation above it. This means 12 times 1,000 to see, just to have that extra symbol. And the rest of it you can do more or less the normal way. This is 300, right? We have a symbol for 100, so you can use 3 C's in sequence. That's the maximum, no more than 3 of the same type. And then you have 45 here. 45. We have a symbol for 50, which is close to that, all right? But 45 is less than 50, all right? So we're going to have to basically subtract in order to get this quantity. All right? What we will do is we will take 50 and subtract 5. If 50 is L, right, and V is 5, then if we put them in this sequence, the V in the front and the L after it, this is a subtraction problem because of the order. V followed by L means subtract these two and you get 45. If on the other hand you had written it this way, LV, that would be 55. Okay. Okay. Next. You know what? The book is suggesting you could do it differently. Let's see. I'm fudging it here. I don't think that that's poor logic, but just to be consistent with what the textbook is saying, let's say you did it this way. 40. I see. Sorry, I'm jumping the gun here. To account for 40, we would have to basically subtract 50 and 10. In order to do that, let's see. You're going to involve the letter L and the letter X, all right? But they can't be in this arrangement because that would be adding. So what you will have instead is the X in the front and the L after to make it subtract. That's 40. Okay. And then to account for the last letter, you put a V on the end. Right. I guess the argument is that this is better than what I had suggested initially because the letters are going from larger quantities down to the smallest quantity. Right? This is bar notation granted, but you have a larger quantity of hundredths, right? Then you have the L and the X, and then only on the end you have this. Okay. Let's get into a multiplicative system. Right. Its name alone is implying the operation that we'll be doing, or employing, which would be multiplication, right? You have to hit this with some alcohol. Maybe I'll do that real quick. Give this a quick spritz here. Don't use my markers. It's getting a little bit sloppy. There we go. Moving on. All right. And I want to mark this too alcoholed up here because then they're not going to function. All right. Let's get into multiplicative systems. And the example we'll have is traditional Chinese. Okay. A couple of fun facts about this. Traditional Chinese numerals are written vertically. So you'll see them written like this, in this orientation. It's more, I guess, like, I suppose, a Western thing to have things more horizontally. Certainly when you're doing multiplication, at least by hand, that's kind of the way we will agree to do it anyway, for double digits and so forth. Okay. Now what you will see is something that looks like this. There'll be an obvious top numeral, and it's usually a 1 to 9, something like that. And then sitting on top of a bottom numeral and this is the multiplier. This is basically the thing that you're multiplying by a power of 10. And just to be fancy, we sort of sandwich these things with a brace. The royal we. So you'll see curly braces to sort of group these things together like so. Okay. That's as it looks. Okay. Now again, to refer back to this table, you definitely need, unless you are familiar with traditional Chinese, and I sadly am not, you have these beautiful characters here, all right, which again to me look like they were done with brush strokes. Again, if you, not to go off on a tangent, but what's interesting to me is that the technology has some bearing on the aesthetic. If you are working with a clay tablet and just a stick, basically, the prettiest that your characters will be would be a wedge shape, like the Babylonians had. Whereas if you're working with a brush, there's some artistry here, a little bit more finesse, right? Which is why these are so nice. Anyhow, what you will see, as an example here, is something like this. Brush stroke, I'm going to have to sort of improvise with my marker here. And then a slightly larger brush stroke underneath it. Probably not doing this any justice, but I'll try. So if you saw something like this, and then for distinction, I'll put this in a different color. A downward brush stroke like this. And then tie them together. Let's see what this translates to. We have, according to our diagram, all right, characters for the quantity of 0 all the way up to including 9, and then powers of 10 after that. So this is more sophisticated than the Roman numerals because we can do multiplication more efficiently. And we have a symbol for 4, we have a symbol for 6. All right? It's not too drastic, not too many extra. Anyhow, 2 horizontal brush strokes is what translates to 2. I'm going to put this just adjacent to it. Maybe put it in the same color would make sense. So you have 2. And then you have a single brush stroke down here, which is apparently the power of 10. Let's see. Is that correct? No, it's just 1. I'm sorry. I'm jumping the gun here again. Make sure I'm not misinforming you here. This stonada. Looks just like 1, which would be 2 times 1, which is just 2, but I want to make sure I did it right. Oh, no wonder I left it out. Okay, sorry. I'm not completing my symbols here. Left it out. That was dopey. Okay. Include, I'm sorry, an extra brush stroke this way. Wondering why I left it out. Must have been drunk at the time or something, I don't know. Okay, so what we have is 10 here. I wish my markers would agree with me today, but here you have it. Alright, so it's multiplication. Alright, normally when we write multiplication, right, we're kind of used to doing this. It's doing that, but just like that. And without using a multiplication x to signify multiplication. But it means the same thing. Alright, so what's the quantity? 2 times 20 is, 2 times 10 is 20. Okay. Let's do a slightly more complicated problem. Okay, let's stick with the scheme of colors here. If we had the quantity, this is exercise 7. Laying in the frame here, good. 538. Okay. And we're going to translate from the Hindu Arabic numerals into traditional Chinese. Let's start with this. Break it up into place values. Just stacked vertically. So if you have 538, think about it this way. It is to start with 500, 30, and then the quantity 8. Round numbers like these, right, can be acquired from basically powers of 10, right? So if you think about this by itself as being 5 times 100, right? We have a symbol for 5, and we have a symbol for powers of 10, right? At least up to 1,000 on our table here. So translate these Arabic numerals, Hindu Arabic numerals, into the traditional Chinese character now. Right? If again you look at this table, right, the symbol that we have for 5 looks like so. And I will try to simulate that as best I can, as I lack experience. This is a brush stroke this way, and this way, and then one through. So it's not very elegant the way that I'm doing it, but it is actually a pretty character. Okay. Whereas the power of 10, pardon me, yes it is a power of 10, but it's 100 is the answer. A symbol for 100 looks like so. The multiplier, a brush stroke this way, and then something of a container here, like that. That's just 500. If we do 30, it would logically be 3 times 10. So the symbol that we have for that is more intuitive, right? It's Roman numeral-esque, if you will, because it's like 3 fingers. It just is more or less horizontal. So you have a brush stroke, a slightly smaller one in between, and a larger one like so. And then the multiplier, the power of 10, is just 10 itself. Is more or less the sort of cross shape. Something like that. Again, stylistically, it would be a little nicer. I'm not doing it any justice, but my markers aren't helping either. Okay. All right. And then there's the quantity 8. Well, 8, because it's part of the established characters, you can go right to the traditional Chinese character, which looks something like this. Sort of a diagonal brush stroke, and then a second one like this. The Hindu Arabic number 538 can be symbolized with traditional characters like so, vertically. Right. There are some special cases though. Let's mention that. The green is a trouble. There's 2 special cases to consider. Firstly, for numerals or numbers between 11 and 19. You don't have to you don't have to write times 10. Or the equivalent of times 10. basically you're just going to just write the symbol for 10 and the extra digit. Here's an example of what I mean. If we were to translate 18, what I'm trying to say is that you don't have to break this up into firstly 10 and then 8 by itself. You're not going to do any multiplication is the bottom line, right? What you're just simply going to do is this. You're going to just have 10 and then an 8. And you'll write it stacked like that. No multiplication. So if you have the character for 10 is again something that looks like this, a vertical brush stroke and a horizontal brush stroke. That's 10 by itself. And then there's 8. You just have to write it like that. That is understood as being 18, as if you added them. The other situation is when there's zeros in the number, either between non-zeros or at the end. To summarize, you have zeros between versus zeros at the end of a number. Let's see. One symbol for 0 is enough. You'll see what I mean in a moment. All right. If you had 2 zeros between non-zeros, you only have to account for one of them. And there's no multiplication involved again. No multiplication. If you have a 0 on the end of a number like 30, or 300 or something like that, the 0 symbol is not included. Put this in red in contrast. Not included. I'll give you examples to emphasize each of these points. Okay. I think I'm going to end up writing with my black a lot just because my other markers are so cheesy today. Let's see. All right. For this scenario, we have zeros between numbers. Let's start with this. Say you had the number 406. If we broke it up into, we'll put this a little bit lower, 406, into its place values to start with, we'd have 400. There'd be nothing really in here. I'm just going to sort of fill the void for a moment with 0 in as far as the tens place, and then there's a 6 in the ones place. This one is basically as we have described it. We, the royal we. It's 4 times 100. But when you get to a situation like this, all right, you don't have to do 0 and then 10. Right? That's really what I'm getting at when I say there's no multiplication for zeros. But writing the symbol is just enough for 0. You don't really have to do multiplication in a case like this. You're just going to write the symbol for 0. As to 6, it's just the number 6. Okay. Let's just straighten out this much because that's really the only thing you have to do. The traditional Chinese character for 4 looks like this. Forgive me again, I know this is not too elegant the way I'm doing it here. But that is 4. And then 100, the power of 10 that you're multiplying by, is this. This is going to be nice and dark. Horizontal brush stroke. And then kind of a container here. And then that symbol. 4 times 100 is 400. We're just going to write the one symbol for 0 rather than multiply to fill in this space, to fill in this place value. So, 0 is the most elegant of all of the characters. It's certainly the most involved. It almost looks like a person's face. A brush stroke like this, and then something like this. And again, do forgive me if any Asian people who are Chinese who are familiar with this see my sloppy handwriting. I'm sorry. I really should be using a brush anyway, right? And then there's 6, the symbol for 6. Which is pretty. It just looks like this. Horizontal brush stroke, like that. And 2 like this. Okay. These in tandem, 4 times 100, 0 for the tens place, and then the numeral 6, all right, are 406 combined. Let's do a situation where you have a 0 on the end. Oh, also, if this was worse, if you had 4006, and there would be a 0 in the hundreds place in addition to a 0 in the tens place. Again, one symbol for 0 is enough, right? You are counting for the thousandths place by the multiplier that would be here. So instead of this character, you'd use the symbol for 1,000. Right. When you have when you have zeros on the end, and I'm just gonna do this here. I'll use the same numbers. 460. Again, break it up into places. Place value, there's a 400 included, there's a 60 included, and then there's technically 0 in the ones place. In the traditional, well, traditional to us, Hindu Arabic symbols. If you address the 400 first, right, it's the same symbols as before. We already established it's 4 times 100. On 60 would naturally be 6 times 10. So we would have the symbols for those. 6, and then 10. And then here's the point in question. Zero symbol that is on the end, right? You don't have to put the character that is this character here, right? Don't write, right, the symbol for 0 because it's unnecessary, right? This is already 60, it's understood. Right? In our decimal system that we have to fill the void. You know? In the Arabic system, right, which is decimal, right, we have no choice, but in the traditional Chinese you don't have to put the 0. Okay. All right, let's get into the Siphon systems. The advantage of the Siphon system that we're going to look at, Ionic Greek, ancient Greek if you will, is more concise in expressing a quantity than say a Roman numeral. Roman numerals, depending upon the number, could be quite long, right? Because it's not working with a lot of characters. It's just working with an I, a V, a 10, X shape, you know, an L, a D, and an M, and a C. Not in that order, but that's a very finite amount of characters to work with. So in order to accomplish anything, as I had mentioned, you have to either add or you have to subtract. The Siphon system that we're going to look at has a lot more characters. Right? It's basically a lot more to memorize, but because you have so many characters to specify so many different things, you can write your quantity much more concisely. You'll see what I mean in a moment. The example we're going to use for this is Ionic Greek, which has basically 24 characters, right, plus 3 obsolete characters, so 27 total. There's 24 characters in the alphabet, and then there are 3 extra symbols that are older than this even. So you have 27 symbols. Okay, what do they use? Well, there are symbols for 1 through 10, and then also multiples of 10. Nice one of these died on. The table here that we're going to use for problems like that is look at this much larger table. These are elegant sort of designs too. You're probably familiar with these, especially as a college student. You've heard of alpha, beta, and so forth. And these are mostly the lowercase letters, I would say. Notice it stops, it goes 1 through 10, and then there's multiples of 10. So you see 20, 30, 40, 50, and our table stops at 900 even. Okay. So, that's very faint. Multiples of 10. Okay. This is build 2. Let's do a couple of these. this is example 9 from our sheet. If you had something like this, a tau symbol, and then pi, which we are familiar with, a lot of us, because of math. This is tau, pi, and epsilon. Right. What does tau represent? Well, if you look at our table right off the bat, you'll notice. Where is it? Tau is here. That's 300. 300. Pi is 80 apparently. And epsilon is 5. So you're just going to basically add these. 385 is what you would end up with. Not too complicated. Again, the difficulty with this system is just that there's 27 characters. All right. And if you're wondering, I don't know for a fact, all right, but I would guess that, you know, people know an amount of numbers that are practical, right? What is intuitive to us is probably just 10 naturally, right? Because we have 10 fingers and 10 toes, right? So 20 is a familiar number even to us, all right? But especially if you go back farther enough in time, right? You would have to figure people, you know, they didn't interact with large quantities too much, you know, unless they were going to count grains of sand, all right? You wouldn't have a large quantity of anything, all right? So you wouldn't need an infinite number of symbols, really. Right? It was beyond their practical needs. Anyhow, this is translating from Ionic Greek to the Hindu-Arabic system. Again, our system that we are familiar with, the Hindu-Arabic system, is the better system, all right? Because you can contrive an infinite number of numbers, right? If those numbers are infinite, that would be very useful, all right? Whereas these systems, the Siphon system, insofar as our table would indicate, all right, you can only go up to quantities like, you know, around 900, you know, unless you're going to employ some kind of an operation. Right. If we're going to go the other way, if you're going to convert from a Hindu Arabic number to Ionic Greek, let's start with this example. Something bigger than 900 is a special case, really. Right. So if you had 1654. This is a special case, right? What you'll see is a sort of superscript, Greek iota is the name of it, and it looks something like this. All right. Sometimes it's a dot, sometimes it's a not. I think that's more intuitive. And it basically means, all right, it's going to be in front of a number, and it means times 1,000. Okay. So let's take this quantity and break it up into some place values again. It's 1,000, first of all. It's 600. It's 50. And it's 4. If you look at the table again for the Ionic Greek alphabet here, we stop at 900, so we don't have 1,000. But what we do have is 1, right? Which is kind of silly, right? So, what's the Greek character for 1? if this could be thought of as basically 1 times 1,000, right, to express the quantity of 1,000, as silly as that may sound. What's the character that we have for just the concept of 1? Alpha, according to the table. So if we translate this as the alpha symbol, and then purposely put a superscript Greek iota in front, something like that, with or without the dot. I like the dot personally. All right. This in superscript is implying that this is 1 times 1,000. It's kind of like exponents, and exponents does involve multiplication, but it's not exactly the same thing. Exponents are the amped up version of multiplication. 600 has a character for it. So what's the character for 600? If you look here, it's chi, which looks like our traditional x. I believe that is the correct pronunciation, at least if Catholic school taught me anything. So it is an x like so. Stylized x, if you will. 50 has a character, which is new. New looks like a V shape, something like that. It gets used in physics a lot. And 4 is delta, lowercase delta. So delta is this sort of elegant, curly, almost musical note shape. So our Hindu-Arabic quantity of 1,654 would be written like this, all right? And not vertically, I'm just sort of doing it the traditional Chinese way. It would be like this. I'll put it right underneath it here. I don't think it's wrong to write it vertically, but this would be more appropriate. Alpha, and make it look like a delta inadvertently, with iota in front in superscript, so slightly higher, slightly smaller font up in the front. Chi, new, and then lowercase delta. This is this. Okay. Let me leave it at that. 2 hours, I think that's sufficient. All right. When you're trying the assignments in My Math Lab, all right, just try section 4.1, and again, have this table on hand. It would presumably help you to have the key, basically. It's like a secret message, right? Anyhow. Thank you guys for listening. Sorry for the hiccup in between. I didn't want to miss that call that I had. Like I said, I called social services, so I really needed to do that. Anyhow, I'll see you on Monday. All right. Take care.